Hi, so in this videos we're going to cover the higher tier numeracy 2019. This is paper 1, it is the non-calculator paper. So Catherine considers the data she needs to collect to find out if people are happy with their bank. Question 1 is how old are you? So write down one set of possible groups that could answer this question. So it asks for age, so an appropriate category would be something like over 60. Something like that. So over 60, another one would be under 60. You only need one really, so saying over 60 would be fine, but the general principle here is not to exclude any value. Question 2, if you have a bank account, how happy are you with your bank? Very happy would be an appropriate one. And then if it asks for something a bit more full, you would say something like happy, intermediate, don't care, not not happy, and very unhappy, something like that. So question 2, Sean and Rodri are making a kite. So AC and DB are the diagonals of the kite. So this is important to note. The diagonals of a kite actually don't look like diagonals. They look like these two. They are these two lengths here because they're not actually not actually lines that form the kite. They're rays. So AE is 22. EC is 28, DE is 20. So Rodri makes a statement about the kite being able to fly in strong wind. The length of the long diagonal must be 120% of the length of the short diagonal. So the long diagonal being AC must be 1.2 times BD. Okay, so given the nature of a kite, so these two lengths being the same, because it's a kite, these two are the same, and these two are the same. So because these two are the same, this is also 20. So with that in mind, then we have that BD is equal to 40 centimeters, and we have that AC is equal to 50 centimeters. So essentially, if I add 20% onto BD, is AC 120% of BD effectively is what we're looking at. So if we look at this, to get there we add 10, and 10 is a quarter of it, so it's actually 25% of it. It's an increase of 25% effectively, so this is timesing by 1.25. So yes, so it's an increase of 25%. So yes is the answer. It is greater than 20%, so it's fine. Okay, so allow me to split these up so that we can see both. So Sean says the best length for the tail of the kite depends on the area of the kite, and here we have this chart that shows various areas and the best length of the tail for these relative areas if they're in this range. Work out the best length of the tail. So we're going to find the area and just see which section it would go into, which chart, which row it would fit into really. So if I look back to here, so these two and these two are the same, and these two and these two are the same. So this top right triangle, so I'm going to call this 1, 2, 3, and 4. So 1 and 2 are the same, so 1 is going to be 1/2, because these are right angle triangles after all of them are. So 1/2, 20 times 22 for this one, so base times height. So this is going to be 10 times 22 equaling 220 centimeters squared. 2 is identical, so 2 is also 220 centimeters squared. 3 is going to be 20 times 28 divided by 2, so 1/2, 20 times 28, which is going to be 10 times 28, which is 280 centimeters squared. And then 4 is identical, as you can see, so it's going to be 280 also. And now we simply add these up. So 220, 280 is 500, and then there's 2 of each. So the total area equals 1,000 centimeters squared. And please feel free to confirm this yourself. And now 1,000 fits into this range here, so the best answer is 3.1 meter tail is optimal. Okay, so let's just finish this bit off. So question 3. An old recipe is given below. Arrabbiata pasta sauce serves 4 people, requires 1 onion, 2 tins of 88 pound, 2 88-pound tin, 0.88-pound tins of tomatoes, and 3 chilies. How many kilograms of tinned tomatoes are needed to make the pasta sauce to serve 20 people? The keyword here being kilograms. So currently this serves 4 people. So first of all, let's find out how many pounds of tinned tomatoes are needed. So 0.88 times 2, that's going to be 1.76 pounds for every 4 people. And now we want it for 20 people, so we're timesing by 5, so 1.76 times by 5. That's going to be 8.8, I believe, but again, using any multiplication method you can, really. So 1.765, and like so. This is how I would do it. 303505, and then extending these out, 08. 0881, and then carrying this down here. The point meets here and it goes down here. So we get it to be 8.8 pounds. And then we simply now need to convert it to kilograms. So converting this to kilograms, we just need to know the conversion rate effectively. The reality is you just need to learn it. It is bookwork, unfortunately, so it may be worth noting. So 1 kilogram is 2.2 pounds. So I've got currently 8.8 pounds, and every 2.2 pounds is 1 kilogram. So effectively, how many 2.2s are in 8.8? And that's essentially 8.8 divided by 2.2, which is 4 kilograms. So 4 kilograms is your answer. A pasta factory in Italy produces 5 kilometers of spaghetti per day. How many centimeters of spaghetti will this factory produce in 7 days? So first of all, let's find out how many kilometers are produced in 7 days. So 5 kilometers times by 7, so it's 35 kilometers weekly. And now we just simply need to convert this to centimeters and then convert it to standard form when we're done. Right, so in kilometers to centimeters, so 1 kilometer is 1,000 meters. And then 1 meter is 100 centimeters. So I could do this formally with just writing this in standard form as 10 to the 3 and 10 to the 2, but I feel like that wouldn't be very educational. So 35 kilometers is equal to times 1,000, so 35,000 meters. And 35,000 meters, and if I times that by 100, that would be 3.5 million centimeters. So now we need to write this in standard form. So to put this in standard form, the number has to be between 1 and 10. So the decimal point currently sits there. I want it there. So it becomes 3.5, and it is 1, 2, 3, 4, 5, 6 jumps. So it's 3.5 times 10 to the 6 centimeters.